Alright, this little screencast is going to show us how to write the names for ionic compounds. And again, to identify an ionic compound, you just have to see that what you have is a combination of a metal with a nonmetal. Remember, metals are on the left-hand side of the periodic table, left of the staircase. Nonmetals are to the right. So here the trick is just come up with the names of each of the three, or each of the two things in here. We only have two elements. We have multiple copies of them, but there's still only two elements. And the first name will always take the name of the metal. So in this case, Ca is calcium. We're going to combine that with nitrogen. If it's just a non-metal, just one of them, it's not one of these polyatomic ions that we'll get to later. Then we're just going to change the ending of the last name to IDE. So this would be nitride. So calcium nitride. Easy peasy. Taking a look at the next one here, we've got nickel and NO3. We got 1, 2, 3 different elements here. That should be setting off alarms to go check your sheet with the polyatomic ions. We've got it in our notes as well as the packet. Ni, found on the periodic table, is nickel. And NO3. NO3. I've got three things here. A lot of people will be tempted to name it using the rules of our covalent naming, but we're not even going to go down that road. You just find NO3 on our sheet of polyatomic ions. We find that NO3 has the name of nitrate, so this is going to be nickel nitrate. And notice I've left a gap here, and that's because nickel on the periodic table, it's up there a couple spaces down from iron, and it's a transition metal. We don't know the charge on nickel based on where it is located on the periodic table. So we don't know if this is going to be nickel 1, nickel 2, nickel 3. We don't know, as long as it's not nickel back. Okay, sorry, bad joke. So what we need to do is look at the charge to what it's bound with. Now you might be tempted, okay, nitrogen's a -3, each oxygen's going to be a -2, so there's 6 plus 3, 9, and there's 2 of them, 18. Don't do it that way. Look at NO3 as a whole, and you find that on your polyatomic ion sheet, you're going to see that NO3 has a charge of -1. Since there's 2 of them, my total negative charge is going to be -2. To balance that off, I've got to have a total positive charge of +2. Since I only have one nickel, that one nickel's charge has to be the entire positive charge. So this is going to be nickel, Roman numeral 2, nitrate. Down here, BeSO4, let's see, 1, 2, 3, 3 different elements. So I'm going to be looking at my sheet of polyatomic ions again. And this is Be, you find on the periodic table. This is going to be beryllium. And beryllium is found in group 2, so we know elements in group 2 have a +2 charge. And then we don't need to worry about Roman numerals for this one. It's not a transition metal. SO4, we find SO4 on our sheet of common ions. SO4 is sulfate. All there is to it there. We don't have to worry about Roman numerals because that's a group 2 element. Group 2 elements always have the same charge. And lastly, let's take a look at this example here. This is copper. Cu is copper. And then SO4 should be familiar. We saw it up here, sulfate. So that's going to be copper sulfate. However, we're not done. Copper, it's a transition metal. Don't know its charge. So we have to take a look at sulfate. We remember up here, sulfate had a -2 charge. There's only one sulfate, so that whole charge is a -2. To balance that out, we've got to have a +2. There's only one copper, so that one copper is taking that total +2 charge. So this is going to be copper 2 sulfate. Now, what if we had an example like this? Cu in parentheses SO4, and there were 2 of them. Well, sulfate has a -2 charge. There's 2 of them, so my total charge is -4. To balance that out, I need a +4, and that must mean that one copper has an entire charge of +4. So this would be copper 4 sulfate. Great, I hope this helps.